Wonder uses technology to create the sounds of the future. I'm Ray Kurzweil. I recently visited Stevie and a number of other innovators who live and work in the age of intelligent machines.
Okay, here I am with my new synthesizer, and this is great. All these different keys and all these buttons, etc. This is incredible. But here I have this visual display. Now, just imagine if you went out here. How will I know what it says? I'd be lost. But because of the technology, because of the interfacing of speech synthesizers with these instruments, I can push the button, know what it's saying by listening to it say.
Hit record button to start and stop record. Sequencer activated. Record new sequence.
Machines that talk to us. Machines that play music. Machines that capture the flexibility of human movement. Machines that learn. These are among the projects and new ideas on the frontiers of artificial intelligence. The science and the art of creating intelligent machines.
Machines are capable of almost anything in principle, and the reason for that is very simple. Machines...
At Yale University, Professor Roger Schank.
The thing that we want to do when we think about artificial intelligence is we want to think about how the daily processes of our lives actually are composed in terms of individual steps. For example, how do I go about composing the sentence I'm saying now? How do you go about understanding it? We don't really know offhand. But what the science of artificial intelligence is about is trying to figure out each step.
Okay, let's put on the microphone.
The real problem is not can machines think, but can people think well enough about how people think to be able to describe how they think to machines.
Stefan Michalowski, a research scientist, helps Robert Yee, a quadriplegic, test a new artificial intelligence system.
I just got involved in this project 3 days ago. I've been handicapped approximately 2 years. I fell down some stairs, concrete stairs, and injured my neck. 2, 3, 4.
Let's try a few things. I've been working on this project to develop a robotic aid for disabled people for the last 4 years. Our final goal is to develop a practical device that a disabled person could use every day in their everyday life to perform fairly simple manipulations in a home-like environment. Things like getting a drink of water or getting something to eat, opening the door, answering the phone, things like that. Okay, let's move the vehicle over to the left now.
Left.
This is the first time any handicapped person has ever worked on this Veterans Administration research project at Stanford University. It is a system in which a mobile robot is learning to obey spoken commands.
Stop moving.
At the Massachusetts Institute of Technology, Professor Marvin Minsky.
Well, what's happened in research in artificial intelligence is rather surprising, I think. Many of the problems that we thought would be very difficult 30 years ago turned out to be very simple. And many of the problems that we thought would be very simple came out to be very difficult. So this is, I think, one of the most difficult sciences that people have ever attempted, the science of intelligent processes, the science of complicated processes. Some of us tried to get machines to solve what we thought were very hard problems, do mathematics, play chess, solve puzzles. And it was quite easy. To get a machine to play a pretty good game of chess took only a couple of years. To get a machine to play master level chess took only another 10 or 20 years. No machine has been world champion of chess, but there's a machine that was world champion of backgammon, if anyone cares, and those things weren't so hard to do. So many of the things that people respect highly turned out to be easy, and yet simple things, the kind of thing that a child does when it ties its shoelaces, that's far beyond anything we can do now. Not just making mechanical hands that could handle the strings, but understanding how loops and knots work, and understanding how the loops contain each other, and what holds a knot together is a very complicated problem. I don't say that a child understands that explicitly, but it has some idea about it.
A very young child can distinguish between house pets. It knows the difference between a cat and a dog. But this is something an intelligent machine still cannot do. Teaching a machine to recognize different images depends upon a computer science technique called pattern recognition. Machines have been taught to recognize the unique characteristics of each letter. In the capital letter A, for example, the angle at the top, the enclosed space, the crossbar, and the concave region at the bottom are 4 such features. Machines can now read the alphabet as readily as any person. Building on this ability to recognize letters, reading machines for the blind can now read those letters aloud, as words, sentences, books.
Now with technology, I can do things that I've always wanted to do immediately, like reading this book. This book is called Blues from the Delta. I can just simply take it on this machine, turn the machine on,
scanner moving to top of page, looking for the first line, and no matter how versatile, the solo performer could never match the sound of blues bands which featured several guitars, a harmonic and drums together.
Everyone wants to feel as if they can be as independent as possible. Everyone really wants to have the freedom of doing, reading, discovering things on their own.
The latest blues sounds. To expand their repertoire.
Technology for me has been like a brother, a mother, a friend. It has been that very thing that I have not been able to do, that has helped me to do it, and that is to see. Without question, it has been another one of those sunshines of my life.
Instead of the machine talking to us, let's see what happens when we talk to a machine. Each word spoken makes a different pattern.
Thunderstorm.
Thunderstorm.
A child can understand those words. Machines are just beginning to. Here again, pattern recognition is the starting point. Intelligent machines now use pattern, new line, recognition, and expert systems to recognize whatever a person dictates in ordinary language, period.
Counterclockwise. West.
The Palo Alto experiment combines pattern recognition with other facets of artificial intelligence.
Mechanically, the system is actually rather simple. It's just the gears and motors. But the tricky thing is the computer control of the robot. There are sensors on the robot. There is the coordination of the motions of the 6 joints of the arm and the 3 wheels of the vehicle. And then there is the whole issue of how do you interpret the user's commands to get the robot to move in the correct way.
Stop moving.
We're very big on speech for a device like this, not just because we're dealing with a disabled user and speech is the obvious input mode for that, but just because speech is so expressive. In most general terms, you can convey an enormous amount of information with just 2 or 3 words.
Hand. Close. Pretty good.
Let's try out, see if it lifts it. What remains to be done is to devise a good natural language interface to the robot. The human user has to be able to talk to the robot in normal English. You have to be able to say things like, go into the kitchen, open the door to the refrigerator, and get me the bottle that's on the third shelf from the top.
What is the ultimate goal of this project?
The robot has to tell the person what it's doing too. In fact, the robot should be able to respond to questions like, what are you doing? Or why are you going into the kitchen? Or why haven't you done what I told you?
Or why did you drop my sandwich?
Why did you drop my sandwich? Where is my sandwich? The computer understands the words right now, but it doesn't understand the sentences. And that's the next step, but it's a big step.
So it turns out that getting food from a kitchen requires a lot of knowledge we take for granted. In computer terms, it's knowledge about a particular domain. Teaching a machine everything there is to know about a kitchen, or any other special area of human knowledge, is another part of artificial intelligence, a methodology called expert systems. At Stanford University, Professor Ed Feigenbaum.
To discover and work on these basic problems in artificial intelligence, we have developed a particular kind of methodology. That methodology calls for working on difficult applications problems primarily drawn from the sciences, from engineering, and from medicine. We do this because we feel that the best way to find a new idea and to test an old idea is to throw our ideas against a hard wall and see where those ideas break.
By visualizing different molecular structures, one expert system enables biologists at the University of California Medical School to actually see molecules that have not yet been created. Simulating biochemistry in the computer, scientists are learning some of the properties of new forms of life. At the University of Pittsburgh Medical School, an expert system is being developed to help doctors diagnose a patient's problems more quickly and with greater scientific accuracy. The system helps the doctor ask the right questions and zero in on the right diagnosis. A study of a similar system found that within at least one medical specialty, the expert system was as accurate as human doctors. Expert systems can help heal the sick. They can also help wage war. Military analysts predict that by the 1990s, artificial intelligence technology will be of greater strategic importance than geography or manpower. Artificial intelligence can also help commercial aviation. Suppose you're flying 40,000 feet over Yosemite National Park. An expert system developed at SRI in California makes it possible for the pilot to see what it would be like to fly through the mountain pass. A variation of this system helps architects and city planners figure out the consequences of putting up new buildings and their impact on the surrounding area. Inside some of those buildings will be the offices of the future.
With artificial intelligence,
Wang Laboratories President Fred Wang.
Interpret that raw data. Let me show you what we can do today with artificial intelligence technology. Show me an office. I think physically the offices aren't going to change very much, but what we do in an office and how well we communicate to other people can radically change. I think with artificial intelligence, computers will be better able to really handle all the nuances of communications, of being able to make sure that people know where the information is, know where the people that they're connecting to are. Pie chart. I think the big thing to remember, though, is that artificial intelligence is going to play a role in making all of us more productive. It's not going to be replacing people, but it's going to be able to really help us work better at the knowledge bases that we have.
Imagine a museum with thousands of paintings and a scholar who wants to see particular works of art that are not on display. Using ordinary English, the scholar describes to the expert system the style and content of the works being studied. Here with a system called Focus Vision, the scholar locates the specific paintings in minutes instead of taking hours or days. Newspapers expand our base of knowledge every day. An expert system called Dummy has been developed to help lay out each page more quickly and accurately. Heidi Kargman.
Rather than telling the program and writing a program and saying specifically, this is what you need to do, what you do in our dummy program is say, this is what I want you to accomplish, you figure out how to do it. That's how it works. That's what artificial intelligence does, and that's what we can see in this program.
We want to get smarter as we gather information. So the problem of learning is really important in AI because you can't expect that if these machines are going to have a lot of knowledge, that the way they're going to get that knowledge is by spoon feeding. You can't expect that what you're going to do is teach a machine every detail about the entire world by typing it in. It's got to grow in a normal way, the way people do. It's got to gather experiences, come to its own conclusions, organize its memory according to its particular experiences.
At Yale University, Roger Schank helped develop an expert system called Chef.
What Chef is a program which attempts to simulate a great Chinese cook. An example of that is Chef. It's been told, find me a dish with beef and broccoli. And it doesn't have any dishes with beef and broccoli. So it looks for what else it has. The problem is that when it finds a beef and green beans, for example, green beans and broccoli actually have different properties. And in the end, broccoli has turned out to be much too soggy given the amount of cooking time. The programmer stores that and remembers this particular failure. So the next time it comes into this kind of situation where it has to do that kind of substitution, it won't be so stupid.
Bad beef and broccoli.
So what it's doing is it's learning to reason about its domain based upon its past experiences. In other words, it's getting smarter on the basis of experience, which is very much a very important thing for computer programs to do. I think the world will change a lot as a result of what artificial intelligence can bring to it. Smart computers would certainly make our lives a lot happier, and a computer chef would make me happy. I don't know about anybody else.
I write programs, programs make drawings. Drawings are made completely by the computer. This isn't the case of computer-aided art making.
Harold Cohen has been an artist and computer scientist for over 20 years. I talked with him in his studio in San Diego on the University of California campus, where he has developed his own expert system to create original art. Is the computer being creative?
I think creativity is a relative term. Clearly the machine is being creative, the program is being creative to the degree that every time it does a drawing that nobody's ever seen before, including me. I don't think it's currently as creative as I am in writing the program. I think for a program to be fully creative, in a more complete sense creative, it has to be able to modify its own performance, and that's a very difficult problem.
The computer creates original art based on rules that Harold Cohen programs. Rules that enable the computer to draw a variety of pictures that are different each time they are drawn. The pictures can be abstract art or a composition with figures that represent natural objects and people. Does it surprise you that a set of even 1,000 rules can then create really fine art?
Yes, it really does. I sometimes find myself looking at one of the drawings and thinking, come on, who are you kidding? Really, a computer did that?
You're in good health, but someday when you're gone, this computer can keep creating original drawings.
Yeah, I've always said that I'll be the first artist in history who could have a posthumous exhibition of new work.
From works of art to the factories of the future, expert systems are becoming a regular part of decision-making we once thought could only be handled by people. Imagine thousands of computer parts and hundreds of thousands of different ways of putting them together to build just the right computer. At Digital Equipment Corporation, the largest expert system in the world, called XCON, is used to configure almost every computer the company makes. Guided by over 10,000 rules, it plans the assembly process, calling problems to the attention of the technicians. It would take several hundred people to do the job now done by XCON. In Milwaukee, Wisconsin, the Allen Bradley factory, one virtually without employees, uses expert systems to handle the complete manufacturing cycle. The control room processes orders from customers around the world. The factory's basic product is an electrical device which can be assembled in about 650 different forms. The factory automatically follows production of each unit through the entire process. It once would have taken 200 workers to do all this. Now it's done by a handful of managers and technicians and a lot of artificial intelligence. The Flying Shuttle, a machine invented 250 years ago. This innovation in the weaving of cloth signaled the launching of the first industrial revolution. It was a revolution that vastly enlarged our physical and productive capabilities. It brought with it profound changes in the way we lived and the way we worked. While jobs were lost, many new industries were formed, and the total number of all kinds of workers increased.
Put your finger under the letter.
Now mankind is on the threshold of the second industrial revolution, a revolution which expands our mental capabilities. The number and quality of job opportunities can continue to increase if, and only if, our educational institutions and training programs can keep pace with the growing demand for technological advances.
Thank you. Yes.
Chairman of the Xerox Corporation, David Kearns.
Well, the statistics are almost overwhelming. We have 700,000 dropouts a year, but almost worse than that, there are 700,000 kids who graduate each year that are illiterate. But we think that artificial intelligence can be a major factor in doing research and learning, and then actually be a major tool for people in the learning process.
As researchers explore new ways that artificial intelligence can be used, they are also developing ideas about how the human brain works. Marvin Minsky.
Well, I have my own theory of how thinking works, and the theory is called the Society of Mind, and in this theory, the idea is that there are a lot of little parts of your brain. Each of them is a specialist in something. One is good at walking, one is good at being hungry, one is good at recognizing objects. And each of these different machines in your head has a different skill. It doesn't know how the other ones work. So we call this the Society of Mind. A lot of little specialists. They each know very little about the others, but they learn how to exploit the others. Each one learns a trick to learn how to use another one for its purposes. And all of this is going on at once. There may be hundreds or thousands of these little, I call them agencies. And so in order to study this theory and test it, we needed a machine which could keep track of thousands of little processes. Perhaps it'll take millions. And that led to this connection machine.
The machine has 65,000 computers connected to each other in complex and changing patterns, much like neurons in our brain. 500 million computer operations take place in half a second. Harnessing this awesome computational ability, scientists can now begin to solve some of those basic problems they once thought were so easy. Recreating with robots the kinds of movements and visual perception a person can accomplish. At Carnegie Mellon University, Professor Raj Reddy.
Here we are embarking on an endeavor which is more complicated than putting the man on the moon and a wide range of other scientific achievements. and there are not enough people working in the field. In 1970, perhaps there may have been a few hundred. In 1985, 86, perhaps there are a few thousand. But in order to really solve all the complicated problems that will arise in this field, we'll probably need a few 100,000 or even 1 million scientists and professionals working on a myriad of tasks to achieve the kind of intelligence that we expect out of R2-D2 or a C-3PO type of robot.
At some point, when machines achieve the capabilities we have, there's no reason they should stop at that any more than there's any reason that human evolution should stop. If people keep working on intelligent machines, I think the machines will also have been made to evolve far beyond what we can imagine now. And how we'll adapt to that, no one can say.
Upward. Right now I have to have a person around forward just to scratch my nose, say. Backward. Being able to bring the cup to my lips made me realize one of the potentials of a machine being able to make me independent of other people.
To realize Robert Yee's future and our future, what we need is knowledge. And this, silicon, the raw material of the age of intelligent machines. It is an age that offers unprecedented hope and unprecedented power. It will take a large measure of human intelligence to use this new power constructively and creatively.